4 vast planets that could swallow Earth thousands of times. Jupiter, with its strange bands of cloud and its great red spot. A world crackling with radiation that can be heard from Earth. Beyond Jupiter was Saturn. How did this planet alone come to have its spectacular array of rings? Stranger still was Uranus. It was known from the way its moons were orbiting that Uranus had been tipped over on its back. Why should this be? Neptune was barely visible even through the most powerful telescopes. What kind of worlds were these? And what could they reveal about the solar system, of which Earth is such a tiny part?
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
In the early 1960s, sending a spacecraft all the way to the giants was unthinkable. Men had flown just a few hundred miles up, in orbit around the Earth. Unmanned probes ventured further, but only to the nearest planets, Venus and Mars.
Signal level has gone way down. Report continuing low signal level.
Even this was pushing the very limits of science.
In 1964, the first spacecraft, Mariner 4, flew by Mars. The spacecraft just barely made it there.
Yes, it's there.
And so the concept of going to Jupiter, which was almost 500 million miles away, Saturn almost 1 billion, Uranus almost 2, and Neptune almost 3 billion miles away, and all 12 years in journey, was not even something one could very easily imagine.
A solution came from a most unlikely source. A young student at NASA's Jet Propulsion Laboratory was asked to calculate trajectories for a flight to Jupiter.
I was a summer student working on my degree at the time. So when I was given the job of looking at the outer planets, I thought that was kind of a make-work project. I was being kind of kept out of the way while the really important business of getting to Mars was underway.
Flandreau discovered something that made the dream of a flight to the giants a real possibility.
Obviously, the first thing is to determine when the planets are going to be in positions where we could reach them. So I drew very careful maps of where the planets would be, and one of the most important drawings was one in which I drew the positions of the planets versus the date. And the thing that caught my attention immediately was that the lines for Jupiter, Saturn, Uranus, and Neptune all crossed in about the 1975-76 time period. In other words, those 4 major planets were on the same side of the sun and in the same general position at the same time. So it gave me the idea immediately that we could do all of those planets with one flight.
Flandreau's discovery was more than just a convenient planetary lineup. Rocket power alone could propel a spacecraft no further than Jupiter. But scientists knew that if a probe approached a planet at the right angle, it would be caught by the planet's momentum, then pitched in a new direction at a greater speed.
The trick you use here is you fire your rocket with enough propulsion to get to Jupiter, which is, after all, a long ways away. It's 5 times the distance of the sun. Go by Jupiter in just the right way that you get a gravitational slingshot effect. That propels you to Saturn. Same trick if Saturn's in the right place at the right time, which can propel you to Uranus if Uranus is in the right place at the right time, and on to Neptune. Same deal. That happens about every 175 years. And it happened in terms of launch date in 1977. And in fact, a former administrator of NASA, Tom Paine, used to make the joke that the last time this happened, Thomas Jefferson was president, and he blew it.
For NASA, this was too good an opportunity to miss. They announced a mission to the giants, called Voyager. It marked a new era for astronomers who had struggled to understand the hazy views they could see through Earth-based telescopes.